One of the most overall detectable physicists, Michio Kaku, has talked about his assessment concerning this issue. Kaku, known for his astounding contributions to the fields of actual science, has recently recognized that the James Webb Space Telescope, JWST, has seen 6 enormous, endless structures that professionals once thought demonstrated incapable of existing. These exposures have the potential to open up new perspectives on how we may decipher the universe. It is therefore both spellbinding and worth looking out for these developments. Kaku is a noteworthy figure in the scientific field, a physicist of American and Japanese heritage. He is viewed as a specialist in both regular exploratory physical science and quantum mechanics. Unlike some more moderate and skeptical analysts, Kaku doesn't belong to that group and has been open to the shocking later revelations of the JWST mission. We are fortunate that this recognized expert has decided to end his silence and offer straightforwardly what can no longer be denied. The enthusiasm and practically comprehensive tone of the well-known physicist are evident in his remarks on the revelations made by the James Webb Space Telescope. He suggests that these discoveries have been the part that has invigorated his interest. We ought to examine the repercussions of Michio Kaku's revelation of these 6 enormous, tremendous systems. Kaku is a scientist who has consistently had the ability to consider new hypotheses throughout his life. He appreciates that Einstein's theories of relativity and Newton's laws are insufficient to grasp the full, multifaceted design of the universe. Kaku understands that the exposures of the new telescope could significantly improve the scientific field, notwithstanding the fact that many of his peers have not been able to embrace this view. This has caused concern and nervousness among both supporters and critics of quantum mechanics. However, this certified understanding brings out laughter from Kaku. The JWST has uncovered the discovery of 6 colossal universes dating back to the earliest periods of the universe. Each of these huge systems contains more stars than our own, despite forming only a brief time after the Big Bang. The group of cosmologists who made the discovery has named these astonishing systems universe breakers, as their reality would change our entire understanding of the universe. Something here no longer fits with the theory of the Big Bang. The Big Bang theory lets us know that the universe was a turbulent place following the beginning event. The first strong objects took several hundred million years to form, and it required endless additional years for these objects to achieve a sufficient density to produce light. The development of complex designs like systems was supposed to happen much later. Some of the newly discovered systems exceed the size of the Milky Way, and their massive magnificence suggests that they were possibly forming many new stars each year, while our own galaxy forms stars only sporadically. It remains disputed precisely when the first universe formed. Scientists have not been able to decide this until recently. The one thing that is clear is that initially, there could have been just single stars or, alternatively, gatherings of stars that eventually came together to form consistently larger structures, ultimately leading to the evolution of dwarf galaxies, which went through mergers and continually developed as shown by previous theory. According to these theories, very advanced and massive systems could not have existed at that time, which raises the question of whether the universe is actually older than previously acknowledged or whether complex, large-scale structures existed much earlier than anticipated. This current situation is challenging for traditional science, which still struggles with this model. Additionally, some areas of physics have firmly dismissed this discovery, highlighting potential errors in the age calculations. Kaku, aware of this, had this to say: "There are many instances of old and misleading theories that stubbornly persist due to the prominence of certain researchers. Many of these speculations were ultimately disproven when fundamental examination revealed their distortions. Consequently, the essential work in any science, particularly in physics, rests with the experimentalists who maintain the validity of examination through precise truth. On Earth, we have essentially no data on the actual origin marks of the universe. The Big Bang theory was laid out in 1927 based on observations of the universe's expansion. This information led to the conclusion that the universe began from a single point and has been expanding since then. At the time, it was hard for people and scientists to imagine a universe with a beginning and an end. The possibility of a universe that had always existed and was infinite in time was beyond human imagination. In fact, even today, scientists still face difficulties in understanding it. However, it is crucial to reconsider these possibilities. These new insights don't fit with what scientists have relied upon for years in the theory of how things came to be. Nevertheless, science has repeatedly shown that reassessment and openness to significant ideas are vital parts of the scientific process, just as much as the confirmation of specific hypotheses and observations. When Einstein was a young scientist, he believed planets were fixed in the universe, and these specific plans involved a defined space. However, we now understand that everything in the universe is moving. Planets orbit stars, stars move within their galaxies at various rates, and entire galaxies move rapidly through space, the ultimate fate of which we still can't predict today. Analysts are challenged to accept uncomfortable revelations, and it is understood that theories are not just hypotheses or significant insights until they are thoroughly tested or confirmed by conclusive observations. The possibility of the Big Bang emerged from the confirmation that galaxies are moving away from each other, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for a long time. Additional evidence, like cosmic microwave background radiation and the redshift of light from distant galaxies, as well as other cosmic patterns, seems to support this theory. However, it is important to remember that those who once believed the Earth was flat and that the Sun revolved around us also had similar kinds of evidence for their doubts until events or technological advancements provided a clearer and more accurate picture. Presently, we are seeing a similar situation. Scientists expected the JWST to validate intuitions about the Big Bang. However, instead, they have found 6 systems that seem to be too large for their age. This reminds us that science is always evolving, and experts must remain open to new discoveries and reevaluate existing theories based on available evidence. Scientists use redshift as a tool to determine specific measurements in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to one another. To understand this, imagine watching a car coming toward you. As it gets closer, you hear the engine getting louder. However, once the car passes you or moves away, the sound changes. This is because the sound changes as the car moves. The same is true for light. When a light source like a distant star moves toward us, the light we see shifts toward the blue end of the spectrum. On the other hand, when the light source moves away, the light shifts toward red or tints. This phenomenon is known as redshift. Physicists have converted redshift values into speeds and distances for assessing quantities in the study of the universe. At any rate, it is significant to note that small errors in these calculations could have enormous implications. The measurement techniques used in the past are now under review, and the results that scientists will arrive at regarding the most recent discoveries related to our universe are exciting. It is important to consider whether these results are truly based on redshift mistakes or whether some scientists are simply denying the facts. This is a question that requires serious appraisal and a careful review of the data and methods used in the investigation. As scientific inquiry progresses, discoveries made by instruments like the James Webb Space Telescope frequently challenge our assumptions about the universe. The ongoing discovery of 6 massive galaxies dating back to the beginning of the universe is one such example. These galaxies, which defy the standard theory of galaxy formation, raise critical questions about the timeline and processes involved in the development of large-scale structures. The James Webb Space Telescope, a replacement for the Hubble Space Telescope, is equipped with cutting-edge technologies that allow it to peer deeper into space with striking clarity. Its ability to detect light from the farthest reaches of the universe provides astronomers with a window into the past, allowing them to study galaxies that formed billions of years ago. The discovery of these ancient and massive galaxies challenges existing models that predicted such large structures should have formed much later in the universe's history. The implications of these discoveries extend beyond astronomy and into the realm of fundamental physics, compelling scientists to reconsider established theories about the early universe. These revelations also highlight the importance of remaining open to revolutionary ideas and adjusting our understanding based on experimental evidence. Kaku has emphasized the crucial role of scientific validation in shaping our view of the universe, pointing out that theories must constantly evolve to accommodate new data. The debate sparked by these discoveries reflects the dynamic nature of scientific inquiry. On one hand, there are supporters who argue that the discovery of early massive galaxies suggests a longer timeline for cosmic evolution than previously thought. This perspective challenges the traditional view that galaxies evolve slowly over billions of years through mergers and the gradual development of smaller objects. On the other hand, skeptics caution against quickly discarding established models based on limited observational data. They advocate for a more cautious approach, suggesting that anomalies in data interpretation or measurement errors could explain the surprising discoveries. Redshift, a phenomenon observed in the light emitted by distant galaxies, plays a significant role in these critical examinations. As galaxies move away from Earth, the light they emit shifts toward longer wavelengths, a phenomenon known as redshift. By measuring the degree of redshift in a galaxy's light spectrum, astronomers can infer its distance from Earth and its speed relative to our own galaxy. This data is essential for developing models of cosmic evolution and understanding the expansion of the universe. However, redshift measurements also carry inherent uncertainties. Small errors in determining the redshift of distant galaxies could lead to significant misinterpretations of their age, size, and other properties. As our understanding of the universe continues to evolve, it is important to approach new discoveries with a balanced perspective. While the discovery of early massive galaxies may challenge our current models, it also presents an opportunity for growth and deeper understanding. As new evidence comes to light, scientists will continue to refine their theories, working toward a more complete and accurate picture of the cosmos. The James Webb Space Telescope, JWST, has made extraordinary strides in our understanding of the universe, unveiling unexpected discoveries that are pushing the boundaries of cosmology. For decades, astronomers and physicists had relied on models that suggested the formation of galaxies was a slow process, taking hundreds of millions of years after the Big Bang. The traditional theory posited that the earliest galaxies were relatively small and that larger, more complex structures developed gradually over time. However, the discoveries made by JWST challenged this model, revealing the existence of 6 enormous galaxies that appear to have formed much earlier than expected, even within the first few hundred million years after the Big Bang. These findings are significant because they could force a rethinking of some of the foundational principles of modern cosmology. The idea that large galaxies could form so soon after the Big Bang suggests that the process of galaxy formation was much more rapid and efficient than previously believed. This discovery could also imply that the conditions in the early universe were different from what we had assumed. The amount of matter and energy available for galaxy formation, the influence of dark matter, and even the processes that led to the creation of stars and galaxies may need to be revisited in light of this new evidence. Another important aspect of this discovery is the role of supermassive black holes, which are believed to reside at the centers of most galaxies. In some of the newly discovered galaxies, there are signs of incredibly massive black holes that could have been formed within the same early time frame. If these black holes did indeed form so quickly, it would suggest that the mechanisms for their creation were far more efficient than current models suggest. This raises intriguing questions about how these black holes might have influenced the growth and evolution of their host galaxies, potentially providing new insights into the relationship between black holes and the formation of galaxies. The unexpected size and maturity of these ancient galaxies also have implications for our understanding of the chemical makeup of the early universe. The formation of stars in these galaxies would have contributed to the enrichment of the surrounding gas with heavier elements, such as carbon, oxygen, and iron. The fact that such a high level of star formation could have occurred so soon after the Big Bang suggests that the processes that led to the production of these elements may have been more rapid and efficient than we had thought. This could change the way we think about the origins of life, as these elements are crucial for the development of planets and, ultimately, life as we know it. Moreover, the discovery of such massive galaxies in the early universe also raises questions about the role of dark matter. Dark matter is a mysterious substance that makes up about 85% of the mass of the universe, yet it cannot be directly detected. Its existence is inferred through its gravitational effects on visible matter. If large galaxies were able to form so early, it suggests that dark matter played a crucial role in the formation and evolution of these galaxies. Understanding how dark matter interacts with regular matter during the early stages of the universe's evolution could provide important clues about the nature of this elusive substance and its role in shaping the cosmos. The JWST's ability to observe these distant galaxies with unprecedented clarity has opened up new avenues for scientific inquiry. As researchers continue to analyze the data, they will undoubtedly uncover more surprises that could further challenge our understanding of the universe's formation. One of the most exciting aspects of this discovery is the fact that it raises more questions than it answers, prompting scientists to explore new theories and models to explain the unexpected findings. It is a testament to the dynamic nature of science that new discoveries often lead to a deeper and more complex understanding of the world around us. The implications of these discoveries extend beyond the field of astronomy. By pushing the limits of what we know about the universe, these findings have the potential to inspire new technologies and methodologies that could revolutionize other areas of science and engineering. The breakthroughs made by the JWST are not just about uncovering the mysteries of distant galaxies. They are about expanding the frontiers of human knowledge and paving the way for future discoveries that could reshape our understanding of the cosmos and our place within it. In conclusion, the unexpected discoveries made by the James Webb Space Telescope are rewriting the book on galaxy formation and the early universe. These findings challenge long-standing theories and provide new insights into the processes that govern the birth and evolution of galaxies. As scientists continue to study these revelations, they will likely uncover even more surprising and profound truths about the cosmos, leading to a deeper understanding of the universe's origins and its ongoing evolution. The JWST has truly opened a new era in space exploration, one that promises to change the way we view the universe and our place in it.